Hello, it's Bud. This lesson is about pockets which can be drilled, milled, or made by using a raster carve region. It also covers some information on conforming vectors that go along with the drilling, milling, and raster. It is made as a supplement to two video lessons that Michael Tyler made, which are in the tips and tricks as issues 35 and 36 from January and February 2011, which cover pocket cutting tips, part 1 and part 2. Let's go to a design board, and this board is designed with a 1/2 inch grid, and I have laid out a rectangle that is going to be 4 inches by 2 inches. And if I unhighlight it, you can see that the dotted line is right on the white lines for the 2 inch and the 4 inch portion of the grid. If I let me back up here now. My board settings, I'm using a 1/16 inch ball nose for the pattern bit, which is the 1/16 inch tapered carving bit. I'm going to apply a carve area, and just for the heck of it, I'm going to make it 0.8 of an inch deep so that we can see a little bit about what's going on. Now if we look really close at this line, especially the top one, we can see that the bit is going to overcarve because of the taper is our first impression, but it's not just the taper that's causing the problem. LHR has now answered on the forum to a related thread where I speak about a problem with the 3/16 carving bit, and that's where this all started. It appeared to be overcarving. They have now answered that a raster carve of a carve region, that the carving bit, whether it's the 1/16 tapered or whether it's the 3/16 straight sided carving bit, because it is not tapered like the 1/16, that both raster bits, since they are raster carves, follows the line with the center of the bit, not the edge. So there is an overcarve in both cases. You can see it here, and we can adjust for it. It's a little more complex with the 1/16 bit than it is with the 3/16 because of the taper. You have to take that into effect, but I'll show you what we do here. I'm going to change the board setting to use the 3/16 ball nose instead of the 1/16, and you can see right away that the cut on this top line appears beyond the white line much more than it did before. Same thing on the left hand side. It's that way all over. It's just the perspective of the wood in my design is the reason you don't see it on all 4 sides the same. So what I have to do is go into the size, and instead of the 4 inch side being laid out to 4 inches, if I want this thing precise as far as where the sides are, I'm going to change the 4 inch side to 3 and 13/16, which is 3/16 less than the dimension I want, and 3/16 is the diameter of the 3/16 carving bit, and it has straight sides. I do the same thing on the 2" side. I'm going to make it 1.813, since I know what the decimal is now. Whoops, I didn't get there. 1.813. And now you see that the line, the cut line, is right at the edge of my grid like it should be. Now in both cases, the bottom of this bit is rounded, so the very edge of this is rounded as well. And in some cases you're going to mill that out with another bit, or you're going to use a chisel. Same thing with the corners. The corners will be rounded. And again, you can use a chisel to square those up if that's what you need. Depending on what you're doing, how you're using this pocket, you may compensate some other ways. I'll show you one thing here that works while I'm thinking about it. If I go up and apply a drill here in this corner and make the diameter let's say 1/2 inch, and maybe I'm only going 1/4 inch, so I can change the depth here to a 0.25. I can move this drill now into the corner. Michael reminds me that some people call this a dog ear or a dog bone. I've got that set up for this corner, and if I do a layout in a mirror for all four, I have that on all four corners, and it's just a matter of positioning it the way I want. And now if I'm putting a piece of product in this recess, say this was a sled, I now have square corners, actually more than square because of this. So that's the way that would go. So if I change this drill to 8/10 like the rest of it I've got, it'll be easier to see. So there you can see that I haven't degraded my sides, but I fixed it so I don't have to use a chisel on those corners. All I have to do is think about how I'm going to square up the sides if I need them squared up. That's just a little extra in that respect. I'll be back in a minute. Now, as Michael shows in his 2 videos, we can also do this pocket using a straight bit, just to make sure I don't mess anything else up. I'm going to put this back to 1/16, that way I don't forget about it. I've removed the carve region, and if I click on my box and again adjust for the diameter of the bit, let's say I'm using a 1/2 inch bit, then this would be 3.5 and 1.5, just to show you the difference. That's my line. And I go select my bit, and let's say I get a 1/2 inch straight, and I make it 1/4 inch deep. Again, you see I'm right on the line with the edge of my bit. And again, I have the problem of the corners being rounded, which I can go into my drill and just make a little pocket. It's easier than drawing lines all over. All I have to do is put a dog bone tab on each corner, and that allows this thing to be free for my squared piece of wood that I put in it. So that shows you what you can do with a straight bit, and you don't have to worry about the bevel on the bottom. And that would not be a raster carve. Well, which no, that would be a pocket cut. And Michael shows how that you can go back and forth within this with connected lines or with other software. And I'll let Michael's videos cover you on that, but just all I wanted to do was show you how the edges will be in that respect. Now let's go over and talk about conforming vectors in relation to raster carves and drilling and milling. So I'll be right back. Okay, here's some text that I'm putting on the board using centerline. And I'm also putting in a vector line, which I'll carve with the, let's say the 60-degree bit. Just so we can see what's going on. Now if I go to the drill, and let's try a drill right here, and let's make it about 4 inches, and I want the depth in 1/4 of an inch. And it's using the 1/8 cutting bit, or cutting bit at this point. You see what happens to the letters. Okay, if I make a rectangle and mill something here, let me mill with the 1/2 inch just to give us something. Same 1/4 inch depth. You can see that it also obliterates the letters. And the same thing down here. If I move this someplace else, it would have the same problem. Now, what I want to do is I want to go back to the text, click Conforming Vectors. Well, wait a minute. Let me do one more thing. Let me make one more rectangle down here, and apply a carve region at 1/4 of an inch. Okay, and let's move this down here so that we can see what happens as well. Okay, now if I go to the text and apply conforming vectors, we can see that I pick up the text here, but the text on the circle, on the drill, or on just a regular carve region is not allowing the conforming vectors to work. It only works on the carve regions. It'll work on a pattern because it is a carve region as well of a different sort. But conforming vectors does not work. I prove it again here with a line that it's conforming vectors because it is a vector line. And you can see the line continues through the carve region, but it does not continue through the milling or the drilling process. And I just wanted to make sure that you understood that. So the 2 points coincide as far as I'm concerned. Pockets, drill, mill, and raster. We have to understand which one we want to use by how we want that edge to be, whether it must be precise or not. Will determine whether I can use a raster and just shorten my distance by the diameter of the bit, or whether I want to use the mill and drill and do the same shortening to give me a straight edge to start with. And on the conforming vectors, we now can see firsthand where the drilling and milling pockets will not allow conforming vectors to do what we want them to do. We have to have a raster carve area for conforming vectors to work. You cannot have a vector over another vector and expect one to conform and one not to conform. It is a raster carve that the conforming vectors was designed for. I hope I didn't confuse things. Again, I say the main thing I'm trying to do is either use my lesson as a precursor or a supplement to Michael's 2 lessons, which are also videos from 2011. They're issues 35 and 36. I hope that helps.